Imagine a weapon so powerful that the sound alone can freeze an entire battlefield. A weapon that doesn't fire in bursts, doesn't pause to breathe, and doesn't rely on heat dissipation the way normal guns do. When it starts firing, it feels less like gunfire and more like a continuous storm of metal tearing through the air. This is not a myth, not Hollywood fantasy. This is the M134 minigun. Originally inspired by a 19th century idea, the M134 minigun represents the ultimate evolution of sustained firepower. While most machine guns struggle with overheating, recoil control, and mechanical stress, the minigun solves these problems in a brutal but elegant way. Rotation. 6 barrels spinning at terrifying speeds, driven by an external power source, turning ammunition into an unstoppable stream of destruction. From helicopters hovering over dense jungles to armored vehicles rolling through hostile terrain, the M134 has become a symbol of dominance, suppression, and psychological warfare. Soldiers don't just respect it, enemies fear it. In this deep dive, we'll explore what the M134 minigun really is, how it works, why it's so deadly, and why it still holds a critical place in modern warfare, decades after its creation. Introduction and historical background. The M134 minigun is a 7.62 by 51 mm NATO electrically driven rotary machine gun, best known for its extremely high rate of fire. Unlike traditional machine guns that rely on gas or recoil operation, the minigun uses an external electric motor to rotate multiple barrels, allowing it to fire continuously without overheating in the same way single-barrel weapons do. The roots of the minigun trace back to the Gatling gun, invented in the 1860s by Dr. Richard Gatling. The concept was simple but revolutionary. Multiple barrels rotating around a central axis to distribute heat and reduce mechanical wear. For over a century, this idea remained largely mechanical. It wasn't until the 1950s and 1960s that the concept was reborn using modern electric power. General Electric developed the M134 during the Cold War era, a time when the United States military was seeking overwhelming fire superiority. The Vietnam War became the proving ground for this weapon. Mounted on helicopters such as the UH-1 Huey, the minigun provided unprecedented suppressive fire, allowing troops to land, extract, or reposition under intense enemy pressure. What set the M134 apart immediately was its sheer volume of fire. Where conventional machine guns fired hundreds of rounds per minute, the minigun fired thousands. This made it ideal for area suppression rather than precision targeting. Over time, improvements in materials, electronics, and ammunition feed systems turned the minigun into a reliable and devastating platform. Despite its age, the M134 has not been replaced. Instead, it has been refined, adapted, and integrated into modern combat systems, a testament to the effectiveness of its core design and engineering philosophy. At the heart of the M134 minigun is a design philosophy focused on reliability through redundancy. Instead of forcing one barrel to endure extreme heat and stress, the minigun spreads that load across 6 rotating barrels. Each barrel fires only a fraction of the total rounds, dramatically increasing lifespan and reducing the risk of failure. The barrels rotate around a central rotor assembly, powered by an external electric motor. This motor controls the firing cycle entirely, chambering, locking, firing, unlocking, and ejecting rounds. Because the firing process is motor-driven, the minigun is not dependent on gas pressure or recoil energy, which means it can fire consistently regardless of environmental conditions. Another critical engineering feature is controlled rotation speed. Operators can adjust the rate of fire depending on mission needs. Slower rates conserve ammunition and reduce barrel wear, while maximum rates deliver overwhelming suppression. The feed system is equally advanced. The M134 uses a linkless ammunition feed, which reduces jamming and allows smoother operation at extreme speeds. Spent casings are often returned to the feed system or expelled in a controlled manner, preventing interference with the weapon or aircraft. This design prioritizes sustained fire, mechanical reliability, and controllability, 3 elements that define the minigun's engineering brilliance. How the M134 minigun works. When the trigger is engaged, electricity powers the motor, initiating barrel rotation. Each barrel moves through multiple stations during one full rotation: feeding, chambering, locking, firing, unlocking, and ejection. At any given moment, different barrels are at different stages of this cycle. This continuous process allows the minigun to maintain an incredibly high rate of fire without relying on heat-sensitive gas systems. Because the barrels rotate, no single barrel fires repeatedly in rapid succession, allowing time for cooling between shots. The firing pin is electrically activated, ensuring consistent ignition. If a round fails to fire, the system simply ejects it and continues, a major reliability advantage in combat situations. Ammunition is stored in large-capacity containers, often holding thousands of rounds. At full fire rate, these can be emptied in seconds, which highlights both the power and the logistical demands of the weapon. This system transforms ammunition into sustained fire dominance, making the minigun less of a traditional gun and more of a controlled mechanical weapon system.